Okay, everybody, here we go again. C++ Tutorial 3 in a couple of parts. So, what is an operator? Well, an operator performs an action or actions on a variable in a program. And as always, there are many types of operators. Can output information, as we've seen already, which is what I'll call the out operator. It can assign values, which is the assignment operator, just one equal, or it can perform arithmetic, plus, subtract, multiply, or divide, and as well as many more things that we'll see. Alright, so the first one up is assignment. Now the assignment operator simply assigns a value to a variable or multiple variables. So a simple example is x equals 5. And this operator can also assign multiple values at once. So you see a quadruple assignment. Triple assignment, excuse me. And the above will assign the value 6 to all three variables a, b, and c. So arithmetic is simple enough. These operators perform addition, subtraction, multiplication, and division of variables. And a special arithmetic operator is the modulo division. Now in math, the modulo division of two numbers is the remainder when the number on the left is divided by the number on the right. So some examples are 3 mod 5, which is indeed 3. 3 does not go into 5 any whole number of times, but there's 3 left. 7 mod 3 is 1, because the remainder when 7 goes into 3 is 1. 12 mod 10 is 2. 4 mod 1 is 0, so the rule applies that anything mod 1 is 0. And 5 mod 0 will give you an error, since you cannot divide by 0. And now we have some relational or equality operators. To see if two things are equal, both sides of a statement have to have the exact same truth value. So for example, 7 equals 5 is false. We'll evaluate to false, since 7 is not equal to 5. And for example, 5 mod 2 equals 1 is true, since the remainder when 5 is divided by 2 is 1. And then we have the not equals, is obviously the opposite of equals. So 8 doesn't equal 8 is false, since 8 is indeed 8. And 7 plus 2 doesn't equal 4 is true, since 7 plus 2 is 9. So just to clarify one thing, a lot of the relational or equality operators you'll find when it comes to decision making, which is the next tutorial, with if and switch statements. Then we have the strictly greater than, which obviously in math, an expression on the left side must strictly be greater than the right side. So 19 bigger than 6 is true, and 4 bigger than 8 is false. And then we have greater than or equal to. So 9 bigger than or equal to 9 is true, and 18 bigger than or equal to 22 is false. And continuing on, we have strictly less than. So you see 9 less than 9 false, 18 less than 22 is true, and less than or equal to 9 less than or equal to 9 true, 18 less than or equal to 22 true. So now there's also some logical operators here. As well, these would also go hand in hand with decisions. The logical AND, which means every element, and I do mean every element of a statement must be true in order for the entire expression to be true. So the truth table, just using booleans here, the only value that will work for AND is true. So if you've taken a discrete math course, you'd know by doing truth tables with AND, true and true is the only one that works. And then we have logical OR denoted by two pipes. And this one is where one or more of the elements are true, for the whole thing to be true. So you see 3 out of the 4 cases work. The only one that doesn't is when they're both false. And then we have a logical not that will invert or negate the logic for a variable or an entire expression. So true simply becomes false, and false simply becomes true. So not 5 equal 8 will evaluate to true, since the initial expression was false. Now the initial expression was 5 equaling 8. So that evaluates to false, and not false is true. And 8 less than 9 is indeed false, is true, excuse me, and the not will make that false. Alright, so far for now this tutorial is concluded. Part 2 of this will show examples using operators as well as the final set of operators. There are just a couple more to discuss.